welcome to the Quantified Health, Wellness and Aging podcast, a podcast about the latest products and services, technologies and people pushing forward a new frontier. Bimonthly S Dryburgh hosts a pioneer for an in-depth discussion. And now over to the show.
Hello and welcome to the Quantified Health, Wellness and Aging podcast. On today's show, we have Nichola Conlon as guest number 21. Nichola is an accomplished molecular biologist specializing in the study of aging as a biologically complex disorder, building on her expertise in molecular biology and years focused on early-stage drug discovery with a leading biotech firm. Nichola co-founded Nuchido to bring potent, life-enhancing scientific discoveries and education to the public with speed and transparency. Nichola has worked to translate recent scientific discoveries into interventions to increase lifespan and health span, recognize that whilst great progress has been made in treating age-related ailments, the focus now must be on reducing the burden of these diseases as we live longer lives. Along with the leading scientists at Nuchido, Dr. Conlon is focused on bringing efficacious longevity products to market in timescales which are shorter than that is typical of the regulated pharmaceutical market. Hello and welcome as guest number 21 on the Quantified Health, Wellness and Aging podcast. Why I'm on?
Yeah. Do you recognise my accent?
I do.
People that haven't got any experience of the UK often think I'm Scottish, but I live quite close, but not quite.
I didn't expect to have you today, so I'm a little off guard and a little unprepared. And we were meant to talk though some weeks ago, but unfortunately you had coronavirus.
Yeah, it eventually got me.
I think it'll eventually get everybody.
I completely agree.
And how was it for you?
Not too bad actually. To be quite honest, it was a bit of an unexpected discovery when I found out I did have it. Because I felt quite fine. I have a daughter. She's 11 at school. She'd actually been full of cold and for a couple of days, and I'd started coming down with the cold as well. So I just thought, typical back to school germs, and thought nothing of it. Then she actually started coughing. So obviously that's a symptom. And in the UK, you cannot cough in public these days. So I thought I better go and get her tested just in case. And I went along with her, obviously, and got a test as well. And I was convinced that they would all come back negative and it was just a cold because we didn't have any of the other symptoms. And hers actually came back negative and mine came back positive. So
that would have been a surprise.
Yeah. If anything, I thought hers would have come back positive because she had a cough. But I mean, I had no symptoms. So yeah, I was quite shocked. So obviously everyone around me that I'd been in contact with and everything had to go in isolation. They all were tested and they were all negative. So obviously I wasn't a very good spreader. I wasn't a super spreader.
Did you not name your enemies too?
No.
Come on, you could have got them in a 2-week quarantine.
But yeah, so it was quite bizarre because I managed not to pass it on to anyone, despite people, even the people living with me in my house or colleagues or anyone like that. And I would say I had the symptoms of a cold. I had a very stuffy nose. So whether I actually had a cold as well and didn't really get many corona symptoms, but the only real symptom I got was the loss of smell and taste. I didn't get the cough at all. I didn't get a temperature at all. I felt a bit achy. I had a really blocked nose, but I think I had a cold as well. But the one thing was the smell and taste, which is absolutely bizarre. I mean, I didn't quite appreciate it till it happened to me. But I mean, smell, it's zero. It's completely gone, and I still haven't got it back. And I think from what I've read and a bit of research, it seems like a lot of people are really suffering with this symptom long term. There are many people that seem to still have lost their smell 6 to 7 months down the line. So I'm quite prepared for it to be a long-term thing. The taste, I'd say 70 to 80% of my taste is gone. I can taste sweet, salty, sour, but I can't taste the taste, if you know what I mean.
So do you forget to shower?
Well, do you know what? It was worrying. I was thinking, oh my goodness, like I can't even tell if I smell myself. But it's okay because I know I don't usually smell. So I'm sure that's not a problem. Have good personal hygiene.
Yeah, we could go lots of places with that. I think I should jump towards your PhD in molecular biology. Do you care to say what you were doing with that PhD in a little bit more detail?
Yeah. So basically, I have just been always incredibly interested in how the body works. Like especially on a sort of cellular level, I just think it's amazing. So when I had an opportunity to do a PhD, I managed to get one that was something specializing in something called epithelial physiology, which is basically got epithelial membranes that surround the lining of your gut, the lining of your cells, your cell membranes, and that they're highly controlled as to what they let in and out of the cells. And basically, some things can pass straight through by diffusion, and other things need help to get through cell membranes. And there are loads of like little channels or active transport proteins which effectively transport molecules across cell membranes. And my PhD was specifically in how all those transport proteins work. So how do you get amino acids, for example, from your gut through the gut lining, then around the blood, and then into the cells where they're needed to build new proteins and cellular components. So that was really interesting for me, because it had quite broad implications, not just on how the body's working, but how can we, take things from the outside and get them on the inside. So things like drugs, nutrients, other molecules. And that kind of led me down the sort of route of drug development ideas for a career. Academia wasn't for me.
Yeah, and so how did you end up going from there and ending up in the anti-aging field?
So, as I mentioned, academia wasn't for me. I felt like I didn't want to be pigeonholed into like a tiny, small part of the body and spend my life looking at that very small section. So because of what I'd done in my PhD, a career in drug development was quite an obvious choice, because obviously they need to know how would you design drugs that actually get into the cells where they're needed. So I actually went to work for a drug discovery company. They were what you describe as an early stage drug discovery company. So they were like right at the start of the development process, which is like, here you have a disease. Now, where do we start? Basically, where do we start looking for drugs that might actually benefit this disease? So there's a lot of research that happens in terms of looking at, what is actually the physiology of the disease in the body, what's causing it, what are the targets going to be, what things can we measure to see if we're improving the disease, things like that. So I went and worked for this company. Now I was really, really lucky in that this company was very forward thinking. So they were very forward thinking in terms of the way that they actually performed drug development, which I can go into. But just on this point.
Yeah, please say something. I'm going to assume it's some kind of systems pharmacology.
Yes, it is. And basically, the way that they did it was they said, okay, you've got conventional drug discovery, which basically has the approach of we call it molecular reductionism, where they say, this is the disease, there's been one protein or one gene or one thing, pathway or something that's implicated in this specific disease. So I know what we'll do to cure this disease. We will target that one protein, one gene, one pathway. We'll design a drug that'll stick to this one thing, and then that'll cure it. Now, in reality, that doesn't actually work at all, because biology is incredibly complex, and doing just one thing never has any real impact on biology. And this is for two reasons. Well, firstly, there isn't a gene that's working in isolation, or a protein that's working in isolation, or a pathway that's working in isolation in the body. It's an incredibly complex network of things working together. You've got a high degree of redundancy of these processes and pathways as well, and feedback and feed forward. And there's all sorts of complex stuff going on, which conventional drug development ignores. The second thing is that drugs do not stick to one thing. They're promiscuous molecules and they stick to lots of different things. They have what we call a footprint. And that's often ignored. And putting those two sort of things together means that conventional drug discovery has a huge failure rate because it just kind of ignores these glaringly obvious problems. And for that reason, I think the statistic is about 0.01% of drugs actually do something that you want them to do that's useful, which is a terrible hit rate. So this company basically had a completely different approach. It was all about based on network pharmacology. So this idea that if you're going to have any impact in biology, you need to kind of view the biology as a network, and you need to work out how you can maximally impact that network. And often what this means is that you have to have a combination approach. You have to target multiple things at the same time. The problem is it's quite difficult to find the right combination of things to target. The way I got into aging was unusual. So, you would never put a drug development company in the same sort of basket as aging research.
Well, you mean back then you wouldn't?
At least back then, yeah. So this was probably seven years ago, and that was really unusual. And the way that I got into this was through Aubrey de Grey.
So where did you come across Aubrey?
So he had actually contacted our company and said that he'd seen the way that we were doing drug development, and said that he thought it was a really sensible way to do it, and he was really pleased that we were doing it. And he said, "Have you ever thought of looking into aging with this approach? Because aging is so complex. It's more complex than any other diseases that we're trying to battle, because there are so many different things going on at once. And actually the systems, the network pharmacology and the systems approach that you take would be ideally suited to look at something like aging, because it actually accounts for that complexity."
That was nice of him to flag that to the company.
Yeah. So basically, that was kind of one of the reasons I kind of got brought into that company. I think that meeting had sort of happened just before I kind of went looking for jobs. And
Which year was this?
my boss,
2016 or earlier?
no, it's probably been, no, it was way earlier than that, probably 2013, 2014. And yeah, so I just sort of turned up on the doorstep of that company saying, "Wow, your company looks cool." And right after Aubrey had just turned up kind of saying, "Have you thought of looking at aging?" And I think my boss at the time sort of put two and two together and went, "Right, I've just created a job for you." So basically my job there was to run the aging project. And, obviously I knew the basic biology of it, but I didn't know the detail and the level of research that was going on at the time. So I spent, a good year just basically going to every single aging conference and learning everything I possibly could off all the leaders in the field, talking to everyone, just really getting to grips with what science was out there, with the focus of basically going back to our company and being like, well, is this worth pursuing in terms of our, drug development? Which obviously, when I'd done all that research, I was like, yeah, this is definitely not Mickey Mouse science. This is like absolutely unequivocal hard data that aging can be slowed and reversed, and we absolutely should be doing something about it. So that's how I got into it.
So what happened with the company?
So that company still exists. I left that company because basically myself and the co-founder of the business basically had become a bit disillusioned with drug development. I went into it thinking it was this great way of which I could help people and get science out to the public, which was totally naive. But it turns out actually it's really hard to get a drug to market. And there's also a lot of things that go on in drug development which I didn't really agree with. So, for example, when one of my jobs was to look at molecules that had what we'd call freedom to operate. So basically, can you patent that molecule? And quite often I'd look at molecules that had amazing efficacy in our screening, and the drug development companies were not interested in it because it was like a natural molecule that you couldn't patent, or somebody else owned the patent in a different indication, and it was just going to be too difficult to try and work out any agreements.
And what about analogs?
Sorry?
What about analogs?
Yeah, I mean, obviously you can start structurally changing stuff, but generally a drug development company likes a new chemical entity that kind of doesn't have any IP around it. It just makes their job much easier. And some things like natural substances, especially things that are kind of supplement type things, it just like don't even go there. It doesn't matter how well they work, it could cure cancer, won't even go there. And for me, that was just really frustrating, because I was like, there are things out there that actually could really help people and people could really benefit from, that have really good safety profiles and really good efficacy data, but this stuff's never going to see the light of day if it goes down the drug development pipeline. So that was the reason that I left. I mean, I'd gone from not knowing a great deal about aging to be like, this is like what my life is going to be about now. Like, I am so bought into it, and I realized the value that it could have to humanity, and that this is how I want to spend my career and my life, teaching people about this and getting people to understand how the science is really changing and what that actually means for us. So, I mean, I founded Nuchido basically with the sole mission, which is to translate this amazing science into products and services that people could use now. So not waiting 15, 20 years for a drug, like actually people could take action right now. And still, but still, I think the key bit is still having the scientific credibility of a drug. So, still having the same level of science, obviously not the ridiculously long clinical trials, but having some really good data to prove that we can bring out products in sort of the supplement and topical areas that actually have good science behind them. And yeah, that's the mission behind our company, as well as to educate people. I see that as a really big passion of mine, to take science and put it in a way that the everyday person.
Okay, and the Geordie accent will help.
Yeah, exactly. And the fact that I'll tell anyone on the bus or train that I'm sitting next to.
Yeah, about anti-aging.
Yeah.
And you mentioned the word services on top of products there, and that stood out to me. Is that a hint to something you may be doing in the future?
Yeah, possibly.
Okay, because when you start saying services, you start thinking of apps and subscriptions and more than just shipping out a container of pills.
Yeah, I think, services could encompass a lot of different things. It could encompass, scientific services, but it could also encompass services for the general public. So people that maybe want to do a bit more for the health than just a supplement, shall we say, or a topical.
Okay, so you willing to drop any more hints or details about the future of Nuchido right at the start here?
I mean, Nuchido's, like I say, the mission is to get products and services to market quickly. We've ticked off one of those boxes. We've got our supplement to market way quicker than you'd ever get a drug to market, and it has good science behind it. The services is still a while off. Also in the background, at the end of the day, our expertise is in drug development. So we have molecules in the pipeline that we've kind of found as a byproduct of our science that are actually drug candidates. So, we're looking at developing those in the background, but we don't tend to shout about that as much, because our main focus right now is things that can help people this year or next year.
Okay, and have you heard of the term orthomolecular medicine?
No, I haven't. No.
Okay, so it just goes back to the 50s and 60s with Abraham Hoffer, and it refers to using megadoses of nutrients to heal disease. And one interesting thing for me is I was very interested in orthomolecular medicine years ago. And then, I mean, many, many years ago. And then in the last few years, I got interested in the longevity market. When I look at the longevity market, it's actually just what was going on in the 50s, 60s, and 70s. with a lot of new naming. Obviously, the sciences came on, etc. And so you'd reminded me of orthomolecular medicine because you use the phrase molecular reductionism, which I thought was quite nice. Can I just read something to you? Because it then reminded me of Daniel Schmachtenberger, I think his name is, on a podcast. I think it was called War and Sense Making. But he said this. I'll read it out to you, which I greatly agree with. So, quote, which is why I think in modern medicine we're quite good at solving acute causation things. If someone gets an acute poisoning or an acute injury or an acute affection, we're pretty good at that. But when it comes to complex chronic illness, autoimmune disease, neurodegenerative disease, psychiatric disease, we don't have much in the way of real cures for those things. We have symptomatic treatments, and we have things that can stop certain parts of the disease pathology progression. And he goes on to say, hey, a new model of medicine is needed. And I know myself that most disease today is that multi-decade long, not single causation. It's a daily glyphosate on your vegetables. It's a lack of vitamin D. It's a lack of nitric oxide. It's a higher stress. It's a higher glucose, and so forth. Have you thought much about chronic disease because it fits your what you're interested in so well, or did you just decide, hey, look, I'll just go to what I think is the root of the tree or a master root and say, hey, look, it's the aging?
Yeah, I mean, I think our systems pharmacology approach is ideally suited to those complex disorders where there's multiple underlying problems. It isn't just a single pathway or something like that that's gone wrong, or like a single gene mutation or anything like that. There's huge amount of complexity, and our way of looking at it deals with that complexity, so you tend to get better outcomes. But I think when it comes to aging, I think that's exactly, as you've just said, it's going to the root of the problem, because all of the major diseases that we suffer as a society now, their major cause is aging. So cancer, Alzheimer's, dementia, cardiovascular disease, diabetes, or your risk of all of them increases as you get older. Therefore, they're kind of like symptoms of aging, and aging is the disease. Therefore, treat the root cause, which is aging, which 10 years ago was ridiculous. Everyone laughed at it. But now all the results are coming out showing actually this is not a silly idea, because you can slow aging, you can reverse aging. And the biggest takeaway from that is that it actually improves the outcomes of multiple diseases in one go. It improves your health span.
You might argue they're not separate diseases for the most part, the whole metabesity.
Yeah, I wouldn't say. And I think this is a huge problem. And again, it's why I think I'd already started thinking this way back when I did my PhD. And I think that's why I didn't like academia, because for me, I felt like I was just being tunneled down looking at this really one specific thing and trying to work out, how it fit in diseases. And I was like, it just doesn't feel right to be looking at disease and the body in this way, because it is so complex. And I think
you were anti-reductionism.
Yeah, molecular reductionism, exactly. And so I think I'd already started thinking that way. And then I think it was when I was introduced to aging, that's when it all became totally crystal clear to me that, you couldn't think of things in isolation in biology. And actually, all of these diseases, currently the way we deal with it, it's like you have a cancer specialist who specializes in cancer, then you have someone specializing in dementia and neurodegeneration and Alzheimer's and things like that. Now, aging is the biggest risk factor for both of them, but those two groups of scientists and doctors will never talk to each other. They have separate conferences, they have separate labs, they read separate journals. And
it was good for the diseases of the 20th century.
Yeah, but not now.
Yeah, I would agree.
Yeah.
So you're into this, I'll call it data-driven holistic model.
Yeah.
But I tell you what's getting missed out, I feel, by those mantras you repeat of the longevity industry is the environment which we're living in, I think, is increasingly accelerating aging. For example, sugar consumption, highly processed carbohydrates, soil depletion, leaving us deficient in magnesium and zinc. Most people would have slower aging if they took the right zinc and magnesium, dirt cheap supplements. And the environment in which we live in, sun creams, etc. I won't go into the whole thing, but I'll just state again that the environment in which we live in is accelerating the aging process. And that seems to get ignored, I feel, by the longevity industry, which wants to sell cures to what the environment has caused instead of trying to fix the environment we're putting ourselves into.
Yeah, I think that is an incredibly important point, and I do agree with that.
With the previous guests, I've kindly asked them to explain something. For example, Tom Chronomics, he explained epigenetics. Gordon Lauk introduced glycomics. I wonder if you wish to introduce an aging topic which hasn't been covered before, just a brief introduction of your choosing. For example, related to your company, I would imagine sirtuins or what NAD is.
Yeah.
Would you like to take a pick of maybe both? Your choice.
I will do both, as they are both work together and they kind of rely on one another, so it makes sense to do both. So basically, NAD was something I came across quite a while ago now. And it was one of the breakthroughs in longevity science that I'd say was quite pivotal, which basically demonstrated that you could do one change in the cell, which was keep NAD levels high, that would have a huge amount of downstream health benefits. And that's because NAD sits at such a critical point in the cell. So basically, NAD, it's found in every single one of your cells, and it's incredibly important. In fact, without it, you'd be dead in 30 seconds because of the
How about mitochondria? Where does that fit?
yeah, I mean, if you didn't have NAD, the mitochondria absolutely would not work. So the first important role that NAD plays is in energy metabolism. So basically, it is involved in glycolysis and the Krebs cycle, which are the cycles within the cell and the mitochondria that actually convert the food that we eat into the energy form that our cells need to perform their functions, which is ATP. And this would not happen at all without NAD. And what NAD does in the mitochondria and in these pathways is it basically acts as it performs what we call redox reactions, which basically mean that it donates and accepts electrons. And if you have looked into NAD before, you'll notice that it's often written in two different ways. So sometimes you'll see NAD with a plus next to it, and sometimes you'll see it written as NADH. And basically, NAD flips constantly between these two forms. And when NAD has the plus next to it, it basically means that it is ready to accept electrons. And when it has the H next to it, it basically means it's ready to donate electrons. And NAD flips between these states really, really easily. And basically, what it does, it's like a bus almost, and it shuttles electrons all over the cell, like picking them up and dropping them off, while it flips between these two states: the oxidized state, which is NAD plus, and the reduced state, which is NADH. Now, in that sort of role, NAD is not actually used up. It just flips between two different states. Now, the other thing that NAD is being found to be incredibly important for is used as a cofactor in various enzymatic reactions. And what I mean by this is that there are various enzymes and other processes and pathways in the cell which basically need NAD kind of as their fuel to function, basically. And these are things such as the sirtuins, which basically is a protein which activates a huge amount of beneficial downstream pathways that are important for good cellular health. NAD also activates DNA repair enzymes, which are called the PARPs. And these are really, really important in repairing any DNA damage in the cell. and DNA damage is one of the leading causes of aging. And there are numerous other things that NAD actually works to activate. Now, in this role, switching on all these cellular repair and maintenance processes, NAD actually gets consumed. So that's why it's important that the cell can actually keep producing NAD to top its levels up, to keep making sure there's a supply of NAD, to keep things like the sirtuins switched on and having their beneficial downstream effects. Now, the reason that NAD is linked to aging is because it's been found that NAD actually declines quite substantially with age. So if you think about it, you've got this incredibly important molecule that is not only helping produce, the energy that you need, in fact, playing a fundamental role in producing the energy that you need, but also activating all these cellular repair and maintenance processes. And if that molecule that's so critical in all these different things is declining in our cells as we get older, then all of these beneficial energy and maintenance processes are going to get turned down because they don't have the NAD that they need. And this results in cellular damage and ultimately aging. So scientists began to recognize this, and they said, well, okay, the obvious experiment to do is what happens if we don't let NAD decline as we age and we actually keep NAD high. So they did experiments in cells and also in mice, where they literally just give a supplement to keep NAD levels high. And what they found was that by preventing NAD levels from declining with age, there was a huge improvement in the health of these older mammals. So things like, improved energy production, increased DNA repair, less cancer, all sorts of things that are associated with health span and the types of metabolic dysfunction and disease that we get as we get older was reversed, or at least had a substantial improvement. And that's just by changing levels of this one molecule in the cell. So that was quite incredible, the results that came from this. And we became interested in NAD because, well, first of all, it's an area of science that for us is more familiar to people. So people are already taking supplements to try and boost their NAD levels, particularly in the US. So people are aware of this science. It's only a small group of people that are aware of it. It's not like a general knowledge, the public know about it. But, people that are really keen on optimizing the health and the longevity are already familiar with NAD. So for us, it was like, right, this looks like maybe a good place to start with trying to get products to people that have good efficacy, that get the science out there. So we looked at how is NAD being boosted at the moment? How were these companies trying to boost NAD levels in cells? And basically, the way it was getting done was similar to the way that they'd performed these experiments in mammals and in cells. And it was simply by providing the cell with more of the raw material that it needed to make NAD. So their idea was that NAD has declined. So,
And you don't want to name people here.
well, it's
when you say them or
it's
groups.
basically the majority of companies that sell NAD boosting products use two ingredients. They use three ingredients. They either use pure NAD, which is questionable as there's very limited data to show that it actually passes through many cell types, the cell membranes, and the jury's kind of still out as to how it actually gets in the cell. That there are some cells like neurons that it does seem to pass directly into, but it looks like from the data at the moment that NAD is just broken down in the blood and then it gets passed into the cell in smaller fragments, which are like the building blocks of NAD, and then the cell has to like reassemble them. The other two common things or ways people boost their NAD is by using something called nicotinamide riboside, or another molecule called nicotinamide mononucleotide. So they are both abbreviated to NR or NMN respectively. So those are both what we call precursor supplements. So they are literally the building blocks that the body uses to make NAD. Now, you do get a boost in NAD by using these products, but it's quite small. It's around, the published data shows it's around 60% increase in NAD. And for us, when we looked at this,
60% sounds awesome.
it sounds awesome, but it can be done much better, and we've demonstrated it can be done much better if you take a whole systems approach. Okay, so we view this idea of trying to boost NAD with a precursor is kind of like molecular reductionism. It's completely ignoring what's actually going on in the cell, the underlying biology that's causing NAD to decline. So to explain this, I always say I get people just to think of the cell as a factory, and say, okay, so if you've got this factory, let's just say it's producing cars, and over the years, this factory's production has really gone downhill. They've got half the car production that they used to have. How would you try and improve production in that factory? What would you do, Lee?
To improve production in a car factory, hire more people.
Yeah. And this is an old car factory.
Hire more machines.
Yeah. They're the first things people say. So do you think it would be a good idea actually just to go, production's gone down, I know what we'll do, we'll just order more raw material, we'll order more steel and more components and hope more cars come out the other end?
Right.
It would be stupid. Like, you actually need to take a bit of a look in the factory and go, okay, what's actually going on and why is production declined? So this is how we view the precursor approach with NAD. It's saying, okay, let's just try and boost NAD by chucking more raw material in and hope the cell makes it into NAD. Now, over the last couple of years, it's become very apparent that the reason that NAD declines is not because the cell has a lack of raw material, it has abundant raw material. The reason it actually declines is because as we get older, our cell becomes less efficient at making NAD and also recycling NAD. So you can kind of throw as much raw material in as you want, but if you don't fix the enzymes in the cell that are actually required to convert that raw material into NAD, you're kind of wasting your money, basically.
So how do they get a 60% increase if you think they have enough fuel in the form of NAD? So
because initially the cell has multiple pathways for making NAD. So there are various pathways that it can go through, but the critical pathway that's important for NAD production in the cell when it's young is something called the salvage pathway. And the way this works is it's really important because it not only makes fresh NAD from fresh precursors, shall we say, it actually recycles NAD. So remember when I said when processes like the sirtuins or the PARP enzymes use NAD, they actually use it up. Well, when they use it up, it gets broken down into precursors. Now, in the cell actually just recycles these precursors when we're young by the salvage pathway, hence the name the salvage pathway, into fresh NAD again. And the problem is that as we get older, this salvage pathway declines and the key enzymes in this pathway decrease, which means that you kind of get, so say you boost your NAD by 60%, the NAD is kind of used once around the system. It's used up by the PARPs, it's used up by the sirtuins, it's broken back down into precursors. Then, because this salvage pathway isn't working, it has to be excreted from the cell. So it doesn't get this opportunity to actually be recycled and sustain these high NAD levels. And this is already known to be a common problem with these supplements because people become what we call methyl depleted. So people often take things like betaine and methyl donors, trimethylglycine, things like that as co-supplements with NAD boosters because they recognize that they get this buildup of this sort of like breakdown products of NAD in the cell. And the way the body deals with that is by methylating it to signal it for excretion from the body. So it uses up methyl donors, which has huge, terrible implications for your epigenetics because the epigenetics really relies on methyl groups. So it's already a well-known problem. So we said, okay, let's look at this from a whole systems approach and actually address all the different areas in the cell that are going wrong as we get older and try and boost our NAD that way. So what we did was designed a supplement that actually address the root causes, essentially. So it increases expression of the enzymes in the salvage pathway that are known to decline with age, which means that the cells can keep making and recycling their own NAD without any new precursor. We also put ingredients in there that reduce the expression of other processes that are actually wasting NAD. Because that's one thing I haven't mentioned. As we get older, our cells become very wasteful of NAD. So you often find you have increased expression of an enzyme called CD38, which increases on the membranes of our cells as we age due to background inflammatory levels. And CD38 just chews up NAD like there's no tomorrow, like it completely wastes it. So by inhibiting this enzyme even just a little bit, you can really conserve a lot of NAD in the cells, so it can go to better use. We also looked at this methylation problem, and you can inhibit the enzyme that methylates the breakdown products of NAD to encourage recycling rather than excretion from the cell, and also make sure it doesn't impact on your epigenetics. So there's multiple things you can do to fix the cell before you even need to put precursors in. And what we demonstrated in one of our first experiments was that we could actually get just as good of an NAD boost, so like 60%, without putting any precursors in, just by fixing the cell's ability to make its own NAD again.
What kind of ages are we talking here for real declines in normal healthy individuals?
Well, believe it or not, your NAD has halved by the time you're 20. So that's a substantial amount, but bearing in mind, our evolution has only made us to be looking to live till we're about 40. So if it's half in every 20 years, by the time you get to elderly levels, you've got a significant decline. Even age 40 to 50, you've got a huge decrease in what you had when you were young. It's quite significant. So it's, this, you really need to address it long before you think you need to. It's quite often is the case, there's things ticking away inside that are going wrong, and they don't appear on the outside until further down the line. But NAD is a classic case. You might not see the real symptoms of low NAD until you're older, but it's already happening inside you. And if there's something you can do about it to increase it, you should be.
So I'm going to jump from your product and compare it to NR and NMN. But before I do that, I need to tackle you a little bit, or at least a little bit of challenge here. Would it not be better to aim for mitochondrial biogenesis, in other words, making new mitochondria, through just exercising well
Yeah.
4 or 5 times a
Well,
week?
funnily
I
enough,
mean, surely that's better than any supplement.
yeah, well, there are natural ways you can boost your NAD, but funny you should mention that, because this is a classic case of how biology is complex. So boosting NAD levels activates the sirtuins. Now, the sirtuins are like pleiotropic. They activate loads of different downstream pathways. And one of the main pathways they activate is mitochondrial biogenesis through something called PGC1 alpha. So actually, just by boosting your NAD levels, you actually improve mitochondrial function, and you not only improve the quality of ones that you've already got, but you actually increase the generation of new mitochondria. And
Have you looked at the supplement PQQ?
yeah, similar. So obviously there are multiple ways you can improve your mitochondria. Just like there are no linear pathways, there's multiple things that can be done. But in terms of, exercise and things like that, so exercise boosts NAD levels. So that enzyme that I was talking about, the one that declines with age, the one that's really important for recycling NAD, is boosted directly by exercise and also by fasting. So even without supplements, there are natural ways that you can actually boost your NAD levels as you get older. And then,
And also the environmental things use up NAD. For example, if you get yourself sunburn, then you're going to need to fix those DNA double strand
Yep.
breaks.
Yep.
And
NAD.
also like Wi-Fi and EMFs, electronic frequencies from cell phones and the environment also seem to cause DNA strand breaks and consume NAD. So electrosmog.
Yeah. So if you have a lifestyle that actually causes more DNA damage, so if you have a poor diet, if you are smoking, if you are sunbathing and going on sunbeds constantly,
Or going on planes.
yep.
Airport security scans and planes. Yeah.
Anything that causes DNA damage to the cell, you will have lower NAD, because the NAD is required to activate the repair processes the DNA repair enzymes. And as mentioned, NAD gets used up in that process. So if you've got more DNA damage, you will be using up more NAD and it will be lower in your cells. And this is what I mean. It's like by that there are multiple things going on with NAD. It is in, just in its the generation of NAD itself, it's incredibly complex. So to think you can fix this problem that's, has multiple reasons that are causing the NAD to decline with one simple thing, just by boosting the amount of raw material that your cell has, is quite naive. And that's what we set out to demonstrate, that actually, never mind putting more raw material in, just fix the cell first and actually look in detail at all these different things that are going on in the cell and the network as a whole, and find out a way to fix it that way. And that's exactly what we demonstrated, that we could actually boost NAD to the same level as a precursor without putting a precursor in. We just fixed your body's natural ability to make and recycle its own NAD. And then what the obvious question was, okay, what happens if we also put some more precursor in now that the body's more efficient? Would you get an even bigger boost in NAD? And that's exactly what we see. So clinical data for our product shows it boosts NAD on average by 242%. So that's 4 times more than the 60% that we just discussed.
As you mentioned, the most common two NAD precursors are nicotinamide mononucleotide, NMN, and also nicotinamide riboside. So NR has been commercialized by Chromadex, who are in a legal dispute. I think it's ongoing with Elysium Health.
Yeah.
I saw something in April where they made some claim that they had won at some court level, but I don't think it's it was. If I look here, it says Elysium Health loses appeal of patent challenge decision upholding validity of Chromadex intellectual property. But I think it's still ongoing. So certainly was taking Chromadex NR, and I was taking 500, half a gram per day. And I must admit, I tried on and off and on and off. I'm age 44. I noticed zero difference.
Yeah, well, one thing with that is that if you look on the recommended dosage on the bottles for any supplements containing NR, it's 500 milligrams a day. If you look at all of the scientific publications that have been put out studying this compound, they always use 1,000 milligrams. So the 60% boost I've just talked about was with 1,000 milligrams.
Yeah, I had considered bumping it up to 1, but it gets quite expensive when you're taking a gram.
It does, exactly.
And people talk about NR being quite unstable. I do trust Chromadex's production, but there seemed to be some manufacturing complexity to it which could make it unstable.
Yeah, well, I think that's why, Chromadex, the patents are for producing it, because I think it's quite tricky to produce. I don't really know about the stability of NR, but I know NMN is unstable, and it's been said that you're supposed to keep it in the fridge. But I don't.
And that kind of brings us to vitamin B3. So vitamin B3, maybe you could do that actually, since you're the expert here. Could you explain B3, niacin, maybe nicotinamide?
Yeah.
When was NR discovered, etc.?
Yeah. So basically, it can be really confusing because all of the compounds that you've just mentioned, which are all available as supplements, are all within the umbrella term vitamin B3. So that they're structurally related to each other, basically. And what you find is that they've just got slight structural changes. And the reason it gets really confusing for consumers is because whoever invented the labeling rules in all their wisdom decided they would make it really complex. So on a label, you might find it might say vitamin B3, then it might have in brackets as niacin. Now, niacin is vitamin B3, or then it might have, it might not even mention vitamin B3, and it might just say niacin, then it might have in brackets as nicotinic acid or as nicotinamide. So people get really confused because they're like, okay, what am I taking? Am I taking vitamin B3, or am I taking niacin, or am I taking nicotinic acid? Like, I just don't really understand. Now, vitamin B3 and niacin are essentially the same thing. There are two forms of niacin, which are commonly, they're not really technically forms because they're different structural molecules, but in terms of regulations, they say they're different forms. Basically, there's nicotinic acid and nicotinamide. Now, they are structurally different. If you look at the chemical structure, they are different. They also have different physiological effects in the body. The classic example is that nicotinic acid causes something called the niacin flush, which basically means if you take a higher dose, you turn into a beetroot and your skin tingles. Now, nicotinamide
For 10 minutes.
doesn't do that, despite the fact that on a label, you'll see them both labeled as niacin. So it's incredibly confusing, and it really should be changed. And then you've got NR and NMN, which again sometimes get labeled as niacin, and then in brackets it'll say as nicotinamide riboside or as nicotinamide mononucleotide. It's not as common, but that does happen as well. And again, they are structurally similar to all the others that you mentioned. They've just got very slight chemical changes. They're kind of like analogs of each other.
But all three get converted to NAD.
Yeah, all of them do. In fact, despite the hype surrounding NR and NMN, nicotinamide is actually the top one that the body converts into NAD. That's the one that the body's continually salvaging via the salvage pathway and converting into NAD. It also happens to be the cheapest.
But nicotinamide doesn't cause a flush.
No, it doesn't.
But it doesn't help.
No.
But it doesn't help with blood lipids, dyslipidemia.
Yeah, and this is exactly the point. So despite the fact that regulatory bodies insist that you label both nicotinic acid and nicotinamide under the name niacin, they have really different effects in the body. So it's wrong that they get labeled in that way.
At the beginning, I was mentioning Abraham Hoffer and orthomolecular medicine of the 50s, 60s, and beyond. He lived to 91. I think he died something like 2006. He recommended strongly that people take 3 grams per day, split into 1 gram doses. So 3 times per day, 1 gram of niacin. So that's the stuff that causes a flush, the vasodilation. And he pretty much had it down as a cure for everything. Heart disease, diabetes, neurodegeneration, schizophrenia. So niacin, has been certainly was pushed from orthomolecular medicine very strongly for multiple decades. And what I understand is this doesn't have a patent on it. This is just a regular vitamin, or actually maybe B3 shouldn't be a vitamin. It should be an amino acid. And what you've done in your product is instead of like with Chromodex, with NR, or with NMN as patents, you've taken the unpatented niacin, and then what you've done is you've combined that ordinary quote vitamin with I'll use the term cofactors, but I don't know if that's technically the correct word to use the word cofactors there, and that's what makes your product.
Yeah. So we stayed away from NR and NMN, obviously because of the patent situation, and also that we found that nicotinamide worked just as well. And a lot of, as you say, a lot of the research into nicotinamide, it's got a huge safety profile and it's got a huge amount of scientific data showing its benefits from many, many years. And we found it worked just as well. And I think the key reason that people argue against nicotinamide is that they say it's a sirtuin inhibitor. So why would you want to use niacin if it's a sirtuin inhibitor? Now, that's questionable in itself. If you look at a lot of the data that they refer to, the levels at which niacin's used are levels that you wouldn't find physiologically in a cell when you're looking at the whole system. So it's already questionable as a sirtuin inhibitor. It might inhibit in a petri dish in a cell, but in a real person, very doubtful that it would. And also there was just as much evidence to show that it isn't a good inhibitor. And I think the key thing from our point of view is yes, if you chuck a load of nicotinamide on a cell in isolation, it probably will mess up some things. But if you are actually looking at the system as a whole and restoring its youthful capacity, the cell never lets nicotinamide build up. That is evident in the fact that when people take precursors and nicotinamide starts building up because the cell can't recycle it, that the cell starts methylating and it getting it straight out of the cell because the cell will not let it build up. So in our product, what we've done is we prevent that buildup of any nicotinamide because we've switched back on that recycling pathway, meaning that any nicotinamide is just continuously removed from the cell and recycled straight back into fresh NAD. So it doesn't have time to hang around in the cell to inhibit anything. And in that case, it becomes irrelevant what precursor you use because you're actually fixing the system and there is no risk
I
of building
understand.
up.
And when you're saying nicotinamide, I think that's the same as
Yes, it
niacinamide.
is,
I
just
think.
to confuse things again. Niacinamide.
And so, but niacin is separate from
Yep.
niacinamide.
Yep.
And so, to be clear, because you were swapping the words there, niacin will cause a flush. It'll help with blood lipid levels, i.e., dyslipidemia. But niacinamide won't help with blood lipid levels.
Niacin as nicotinic acid will.
Yes.
Niacin
Yes.
as nicotinamide, or its other name, niacinamide, which is the same thing, won't.
Yes. Okay. And so here's a big question I want to ask you. How are you measuring NAD levels? And that was a core reason I wanted to talk to you, was because I heard many times over that you can't measure NAD. There's a company, a lab in California, but it's expensive and time consuming. And then I heard you were measuring it. And how are you measuring NAD?
Yeah, so you cannot measure NAD on a consumer basis, which I guess is how you were investigating it. You absolutely can measure NAD if you have the right expertise and the right equipment, which is often restricted to academic labs who specialize in these particular types of analyses. So the gold standard for measuring NAD is something called liquid chromatography mass spectrometry. Which basically uses liquid chromatography to take an analyte, like a sample, like a blood or whatever, and actually separate out all of the different NAD metabolites, because NAD exists as NAD plus, NADH, NADP, NADPH. There's loads of different things NAD is broken down to in the body. So the liquid chromatography basically separates all these different things out based on the mass. And then when you've separated it out, you basically run it through mass spec, which is quite a complicated process. But essentially what it does is it then can quantify what you've actually got in that sample and how much against reference standards. And that's the gold standard way to measure it. And
But it'd be awesome to be able to measure your NAD levels throughout the week.
yeah, so we've done that.
I don't know the cost level of this. Is it ever going to come to the market that you could even go into a blood lab, send the blood away, and get an idea of NAD levels? I would love to know how my NAD levels do in the week, and also how they change year to year, almost as a biological age measure.
So I would be very doubtful that this will ever be available as a consumer test. And the reason I say that is, people can become experts in measuring it, but it's the process of getting it out of the body and to the lab in a very quick space of time. So NAD is incredibly unstable just by the very nature of what it does. It's made to change its structure very, very quickly. So to flip between different forms, and things like temperature and processing and handling can really influence this. So if you want to be really accurate when you are measuring NAD, the way you have to do it, which is like the way we would do for our clinical trials, is basically we draw the blood out of the person. It goes straight on ice, and then it immediately goes to a room next door, which is a lab, which will then process that blood sample for analysis. Now, this creates a huge logistical problem for anybody trying to develop an NAD test that consumers can use, because there are many tests these days where you take a finger prick blood test, or you get your doctor to take a vial of blood and send it off. Like, that is not an option with NAD, because it would just simply be degraded by the time the lab got it, and it would be useless. And that's the major challenge. So unless somebody or some lab comes up with a way around that, I don't think we're going to see a consumer-friendly NAD blood test anytime soon. Unfortunately, it's restricted to academic labs or like clinical research organizations that have specialists in mass spec. So we work in partnership with universities basically to do our clinical trials, to be able to measure the NAD
Did you
reliably.
publish papers on these NAD increases?
Pardon?
Do you have papers out in support of these, whatever you claim 260% increase in NAD?
Yeah, so we don't have a published paper. I've presented at a conference, and we have the poster that I presented at a conference of our pilot study, which is on our website. But we are in the middle of doing a 24-person double-blinded placebo-controlled trial, which will be published. That's been delayed due to COVID, unfortunately, as with everything else in the world. But that will be published, and that's a very well-controlled clinical trial.
So that cohort is 24. For your poster, was that not just a single person?
That was two people. So that was male and female. And for that, we did quite comprehensive blood work on them, because one of the issues that I have with some of the NAD results that are published just in general is that NAD fluctuates throughout the day. So it's circadian in nature. It follows like a cyclic pattern. So at some points of the
Yeah, it's
day,
like cortisol.
your NAD's high, some points it's low. And there's never really any information on published papers of when they do their NAD tests. So the reason I'm highlighting this is because if you measure someone's blood throughout the day, just like what you were talking about wanting to get done, what you find is, there are parts of the day where their NAD is quite low, and then parts where it increases. And the increase that you get, say, within a few hours, can almost be like 60%. And that's just a natural fluctuation. So my argument has always been, if you're not really, really precise at where you're measuring NAD levels, how do you know that you're actually getting a real effect, and you're not just measuring a natural fluctuation that was going to happen anyway? So in those pilot studies, the reason we only had a small number of people is because we literally had them on a cannula for 12 hours across every day of the week, and we're taking blood from them every 2 hours to basically establish what their natural NAD fluctuations were. So we have graphs that basically demonstrate, like, this is the point where these people are always low NAD, and this is where their high peak is. And then what we did was we then put them on the supplement, and we used these graphs to basically decide where we would measure their NAD. So for example, I think for the female, her NAD was always lowest at 4 p.m. Therefore, we knew that if we were measuring her baseline blood at 4 p.m. and after the supplement at 4 p.m., we knew that any increase we were going to get was actually a real increase, and not just because we'd been quite relaxed about when we were measuring the blood samples. So I think that's a big limitation of some of the data that's out there. So yeah, that data will all be tied up within the bigger clinical trial paper when it gets done.
Just like David Sinclair used fat, sick mice, or mice on bad, poor diets, how do I know you didn't select 2 sick human beings who don't exercise?
So in general, for any clinical trial, you have to pick people that don't have any like medical criteria. You pick people.
That's not much. These people might never have exercised in their entire life.
They might not have, but I think the main thing is whether they've exercised or not. It doesn't really matter, because you've measured the baseline beforehand, and all you want to demonstrate is that you have actually increased NAD, but via.
I would like to take the same people and have them lift weights a couple times a week, and then measure the NAD and see how it performs against the Nuchido product.
I think in an ideal world, people would do both. However, we both know that some people just want to take a pill and don't want to go to the gym. which is unfortunate. I'm definitely an advocate of do multiple things, and multiple things are the way forward, whether that's multiple interventions within a cell or multiple lifestyle interventions. I think is
I
incredibly
agree with you
important.
about that, but I think you'll gather I try and fix the things that don't cost anything first and can have the maximum leverage,
Yeah.
then add supplements on
Yeah.
top.
Well, exercise and fasting is to boost your NAD.
And I actually, I've tried Chromadex, as I mentioned, but listen, I've tried it for years on and off. I'm not noticing a difference. So what I wanted to do was order Nuchido, which is another reason for talking with yourself. I don't think you post to Europe though.
No, we post worldwide. Yeah.
Oh, that's
Yeah.
awesome. And and so I don't know if I know we're meant to stop now. Do you have a couple minutes to discuss ingredients, or do you have a hard stop off?
Yeah. Yeah. I've got a couple of minutes left. Yeah.
Okay, I'll try and fit this in because, as I say, I want to switch to Nuchido, and that's a company name actually, is Nuchido, and your product you've called it Time Plus.
Time plus. Yeah.
Okay, and partly the reason I wish to take it is I wish to see if I feel a subjective effect since I can't measure the NAD, and also because I'm playing with the Glycan Age product.
Yeah.
Uh,
Interesting.
and I know Nicola um, Lauk from Glycan Age. I know she ordered the Nuchido product, and she's also seeing if it has an effect on Glycan Age because Glycan Age appears to be a test that is very sensitive to lifestyle change. It's a perfect blend between not being as long term as epigenetics, but not being as acute as blood samples. And so I'm really interested in playing with their test box. And as I say, I want to test the intervention of Time Plus. And I heard you say, Time Plus outperforms NR, NMN, and these are huge, bold claims. And these are profitable, these are sizable money precursors. And so people I saw said, oh, but they haven't said what their ingredients are. And I found it must have been some time ago because I looked at the website today and I see the ingredients here. And so I look at the product information and I instantly see it has zinc in it of 10 milligram, which is, it's not high, shall we say. I'm not sure why the zinc is there. But instantly see alpha lipoic acid,
Mm.
ALA.
Yeah.
I take six. I recommend everybody takes ALA, and 600 is a nice dosage. So if you buy this Time Plus product, I would recommend you stop taking the ALA product that you take. Right? Do you want to say why ALA is in that product?
Yeah.
I know about how it's for mitochondria, blah blah blah, and maybe say a little bit more, maybe about inflammation, etc.
Yeah, basically, so ALA is in there because we know that ALA actually activates a cellular energy sensor called AMPK. So remember, I was speaking about fasting and how that puts your body into a state of energy deficit almost. Well, that activates AMPK. Now, ALA is like a mimetic of that. It actually does the same thing. And when you get activation of AMPK in the cell, it actually leads to increased levels of NAD. And basically, there's a couple of ways it does this. So it promotes the conversion of NADH to NAD plus. So remember, I said they flip between them. Well, although they flip between them, there's a favorable ratio that you want in the cell, and that's that you want a higher level of NAD plus to NADH. And as we get older, this ratio becomes out of whack, and basically you drift more towards having more NADH in your cell. So ALA actually activates another pathway called NQO1, which actually converts NADH back to NAD plus. So that's one way, and that it actually increases NAD levels in the cell directly. Obviously, ALA is also like a really powerful antioxidant. It activates NRF2, things like that, which are always a good thing because if you've got less damage in the cell, you've got less cellular repair switched on, and you're actually conserving NAD levels because you don't need as much to repair things.
Yeah, so I strongly recommend ALA, and as I say, if I take this product, I'm going to drop off in the product I do take.
Yeah, and also just to know, always make sure that you take the R version of ALA. You know, it has two versions.
Yeah, please explain that. And I agree with you, but I'd love you to introduce that.
Yeah, so you've basically got R or S form. So you'll see it on, well, to be honest, actually, most labels don't put it on, which is a telltale sign. But if the good companies will label it. And basically, you've got ALA in its R form is like its natural form, and in its S form is like stands for synthetic, and it's like its unnatural form. Now, there's been plenty of studies to show that the R form is actually used readily by the body, but the S form isn't, and the S form doesn't have the efficacy that the R form does have. So some products have complete S ALA, which is absolutely useless. Some products have a 50-50 mix, and this is the most common form of R and S. Which is okay, but you just have to bear in mind that you're getting 50% of the efficacy. The best form is RALA, pure RALA, and that's what we've got in our product. The caveat with this is it's expensive. It's really expensive.
And so that's nice. You've got the R form in there, and the label doesn't say. So you might want to add that
Yeah,
for
that's
people
a
who
good
do
point.
know.
I should practice what I preach.
I see you've got vitamin C, but it's only 20 milligrams. So I guess that's just for manufacturing and shelf life
Yeah,
or
so, well,
something of
for the
that
vitamin
nature.
C and the zinc, we kind of refer to them as supportive ingredients. And the sort of thinking behind that is that a lot of people already take a vitamin C and zinc supplement, like just in the multivitamin alone. So we were conscious that a lot of people want to continue taking multivitamins. So we didn't want to put a high dose of vitamin C and a high dose of zinc in, and then like they're overdosing on things that people commonly take. But at the same time, we understand that some people might just take this product, and actually it's better to have vitamin C and zinc at a level that's been proven to be efficacious for those people that don't get any vitamin C and zinc, but not put it in at such a high dose where it's going to tip other people over the edge. But I mean, in general, we wouldn't recommend people to take products that contain the same ingredients, just because, as you've already noticed, a lot of our ingredients are at the high level of the acceptable amounts to take already.
The levels that you have are in no way dangerous. Only, I mean, even remotely. But the only possible exception to that's your green tea extract, the EGCG. So I also take that each day.
Yeah.
And that's one where I would definitely make sure I
Yeah,
don't
don't
take
double
too
up.
much of it.
Yeah.
So maybe you want to just mention the 300 milligrams of EGCG that's there, maybe catechins, flavonols,
Yeah.
and okay.
I mean, the main one we're interested in the green tea extract is the EGCG. So, within our formula, that's used to inhibit an enzyme called NMN, which is the enzyme that increases with age that methylates nicotinamide, and causes it to be excreted from the cell rather than recycled. And its expression of that enzyme increases with age, and inhibiting in that enzyme promotes recycling of NAD within the cell. So specifically, that is what that does in our formulation, and the level that it's at is basically the highest level we can put it in at to comply with the legislation and the regulations in the countries that are our main markets, that being UK and US.
The ingredient, I don't know what it does, is that the botanical blend. I don't know why you have I can imagine why you have the botanical blend, but maybe you want to comment on that. And I don't know about that rutin from Sephora.
Yeah, so Sephora japonica, basically it contains several powerful flavonoids, quercetin, rutin, troxrutin. You've probably heard of quercetin more than rutin. And basically they were selected for our formulation because they actually activate the NAD salvage pathway enzyme NAMPT. So that's that critical rate limiting enzyme that declines with age. They are known to activate it. So they are, really important in our formulation to improve that recycling of NAD. And on top of that, they have huge other benefits, antioxidant, anti-inflammatory, and quercetin itself also falls into a category of other active ingredients, which we won't go into, but they're called senolytics, which actually remove senescent cells from the body, which are another huge discovery in aging research. So it does have some other benefits there.
But you don't have enough to act as a senolytic.
we have some pretty high active ingredients in there, but I think the reason it says a botanical blend is, I'm sure you can appreciate, that we can't give away the values of everything that we put in, otherwise someone would directly copy it.
I completely understand. It reminds me of El Nutra with their fast mimicking diet. People have been trying to engineer a vegan keto diet and copy them also. So the other thing in my mind is I want to be sure when I take products that they're not full of heavy metals, particularly if the ingredients are sourced from China.
Yeah.
And so, do you do lab analysis on batches, etc.?
On
Because I really don't want.
Yeah, no, that's really important. All of our product, it has all heavy metal analysis, microanalysis, everything is analyzed when the raw material comes in, and then it's analyzed again when it's blended in the product, just to make sure anything hasn't been contaminated or anything.
And where are you doing the blending?
Pardon?
Where are you doing the blending?
That at our manufacturer. So we have UK and US manufacturers in GMP FDA approved facilities.
Okay, so you're definitely checking the source ingredient.
Yeah, and I
for
think
contamination.
This is where my sort of background in drug development is quite handy, because we don't have to go at the level that drug development goes to, but because that is the way I've been brought up, so to speak, it's incredibly important for me. And when I see some of the things that go on in the supplement industry, it does make my toes curl.
Last two questions. The first is, where can people find out more?
So they can go to our website, which is www.nuchido.com. And also they can follow us on social media. We've just launched a YouTube channel, which has a couple of videos that I've done, mainly just sort of regurgitating some presentations I've done recently that people found interesting, kind of explaining NAD in more detail and how our product works in more detail. And also people can follow me. I generally you can find me on Instagram most of the time. I try to just keep having little updates of different scientific things that are happening in the field, but really try and put them more in the layperson terms, so people, a lot of different people can understand them. And my Instagram handle is just at Dr. Nichola Conlon.
It should have been like Aging Geordie or something like this, something catchy.
I'm sure there's quite a lot of people that are listening that are probably like, what on earth are they talking about? What is a Geordie?
The transcription list will have fun. And the very last question, easy one, right, is you said aging is an inflicted cascade disorder. Could you finish out by explaining what you meant by that?
Yeah. So what I mean is that there is not a single one thing that's happening. And actually everything is highly interlinked. So if you take all the hallmarks of aging, things like mitochondrial dysfunction, DNA damage, senescence, there's a huge list of them. It seems to be growing. Basically, you can't look at any of them in isolation because they're all somehow connected. So, for example, one hallmark of aging is DNA damage. Well, that is linked to mitochondrial dysfunction, because when mitochondrial dysfunction happens, you get reactive oxygen species which damage things. So that leads to DNA damage, which is the other hallmark. And then you've got DNA damage, which then has an impact on things like senescence, because when cells get too much DNA damage, they then become senescent. Then senescence then impacts on other problems, such as senescent cells secrete lots of inflammatory junk, which leads to chronic inflammation, which is another hallmark. Then chronic inflammation then goes back to DNA damage because it's damaging things, and that then and you can see it spirals. So what I mean by inflected cascade is that it's like a cascade of one thing sets off another, but then they all feed back to the first thing and make that worse, which just makes the whole situation worse. And that's why it's really important not to look at it with a molecular reductionism approach.
Yeah, it could be explained in kind of Scots in two words. The first word would be increasingly, and the second word, I want to keep a clean content for Apple would begin with F and end with D.
Yeah.
Would you
that
agree?
one.
That's a simple explanation.
That would be the way to describe it.
And do you not find that depressing?
No, because I feel like I've got the power and the knowledge to do something about it, but I can completely understand why the majority of the population view aging as depressing and inevitable and something that we can't do anything about, and therefore just say it's just like a natural life process and kind of give up. I don't view it like that at all, because I know there are things you can do, and there's a lot of really clever people working on that. And that's my mission, to teach people what is actually happening and how it shouldn't be viewed as depressing. And actually, there are very simple things you can, put into your own life that could make you age much better.
The next generation, or the generation coming up now, it's going to be a completely different world for them.
Oh, absolutely. We've got this life trajectory at the minute, which is, I always say, we're born, we learn, we earn, we retire, we expire. That is going to completely be thrown on its head, I think. That's what I would predict.
Yeah, and unfortunately, we're kind of at a dark place at the moment where I read the average American now has 19 years in sickness towards the end of life.
Yeah.
2 decades almost.
Yeah, that's
very sad.
Yeah, that's nearly a quarter of your life. It's crazy. Like, if somebody told you there was something you could do to stop that, wouldn't you do it?
Absolutely.
Yeah.
Nicola, I greatly appreciate it. I'm sorry I overshot with the time today, and I really appreciate you coming on.
No, it's been great. Really good to talk to you.
Cheers.
Thank you.
For more information, please see hyperwellbeing.com or follow Twitter @hyperwellbeing.